In this lesson, we will determine equations of parabolas given the focus and directrix. The first example, we're given the focus is 3 comma negative 1, and the directrix is x equals negative 3. Let's go ahead and plot the focus and sketch the vertical line x equals negative 3, which is the directrix. For the next step, let's sketch a segment perpendicular to the directrix, starting at the directrix and ending at the focus. The vertex will always be the midpoint of this segment, which indicates the vertex is 0, negative 1. And now we'll make a rough sketch of the parabola. We know the focus is inside the parabola and the directrix is outside the parabola, and therefore the parabola will open to the right and look something like this. Whenever the parabola opens left or right, the equation will be in the form of the square of y minus k equals 4p times the quantity x minus h, where h comma k is the vertex, and the absolute value of p is the distance from the vertex to the focus, as well as the shortest distance from the vertex to the directrix. If the parabola opens to the right, p is positive. If the parabola opens to the left, p is negative. In our case, we know the vertex is the ordered pair 0, negative 1. From here, notice the absolute value of p, or the distance from the vertex to the focus, is equal to 3. And because the parabola opens to the right along the positive x-axis, p is positive 3. And we know h equals 0 and k equals negative 1. This indicates the equation of the parabola is the square of y minus k, which is the square of y minus negative 1, equals 4 times p, or 4 times 3 in our case, times the quantity x minus h, which is x minus 0. Simplifying, we have the square of y plus 1 equals 12x. If we wanted to, we could solve for x by multiplying both sides by 1/12, which would give us x equals 1/12 times the square of y plus 1. Let's look at a second example. For this example, the focus is negative 2, negative 2, and the directrix is the horizontal line y equals 2. Again, let's sketch a segment perpendicular to the directrix to the focus. This segment here, the midpoint must be the vertex, which indicates the vertex is negative 2, 0. And we can also make a rough sketch of the parabola, again, because the focus is always inside the parabola and the directrix is outside the parabola. Notice now the parabola opens down and looks something like this. Whenever the parabola opens up or down, the equation is in the form of the square of x minus h equals 4p times the quantity y minus k. Again, in our case, the vertex is the ordered pair negative 2, 0, which indicates h equals negative 2 and k equals 0. The absolute value of p is still the distance from the vertex to the focus, this distance here. Notice the absolute value of p in this case equals positive 2. However, because the parabola opens down in the direction of the negative y-axis, p is negative 2, not positive 2. This is all the information we need. The equation of the parabola is the square of x minus h, which is the square of x minus negative 2, equals 4 times p, or 4 times negative 2, times the quantity y minus k, which in our case is the quantity y minus 0. Simplifying, we have the square of x plus 2 equals negative 8y. If we want to, we can solve for y by multiplying both sides by negative 1/8, which gives us y equals negative 1/8 times the square of x plus 2. Either form of the equation should be acceptable. I hope you found this helpful.